In this problem, we're going to talk about the work energy theorem. So what we need to remember is that the work delivered to a system is equal to the change in energy of that system. So if the work is negative, then the change in energy will also be negative. And also remember that the work can be written as the force times the distance along which the force was applied, assuming that the force is constant. So what we have in our problem is an accident in a road where a car left a skid mark for 78 meters. So it means that the car skidded uh, in the road for 78 meters. And the coefficient of kinetic friction between the road and the car is 0.3. Given this information, our goal is to find what was the initial speed of the car. Well, notice that the change in kinetic energy of the car is equal to the final energy, which is 0, minus the initial energy. That's 1 half of mv squared. So the change in energy is minus 1 half of mv squared. The work is the work done by the friction force on the car. So that's minus the normal force times mu times d. Now notice that the minus is here because the friction force um, makes the system lose kinetic energy. So the work must be negative. It The work causes the speed of the car who's suffering, who's under the influence of the friction force, to decrease. So the work must be negative. It points in the opposite direction um, of the motion. So this is minus mg mu d, since the normal force must be mg. And equating the two, we have that 1 half of mv squared is equal to mg mu d. Notice that the m's cancel out, so the mass of the car doesn't matter. The exercise even asks us to justify it, and that is the reason. The masses cancel out. So the velocity is the square root of 2g mu d. So this is the square root of 2 times 9.8 meters per second squared times 0.3, that's mu, times d, which is 78 meters. So v is equal to 21.4 meters per second, which is the answer to our exercise.